Hello everyone, I'm Mo Sanjari from Arkansas Tech University. I'm currently a teaching assistant over at Mechanical Engineering Department. So we've decided to start teaching engineering equation solver software for mechanical engineering students. It has a lot of benefits for them. It can solve nonlinear algebraic equations. It can solve differential integrals, doing optimization, performing analysis, plot a lot of quality graphs and diagrams. So I've decided to break it down for you lesson by lesson. So whether you are a student from our department or someone eager to grasp engineering equation solver, you're more than welcome for this tutorial. And I hope these tutorials guide you well. The software, you can install engineering equation solver on a Mac machine, which I'm using a Mac OS operating system right now, but I'm using a virtual machine to access a Windows operating system from a web browser. So you can easily install on Windows. And I'll probably show you on a separated video how to install engineering equation. It is pretty easy. So but I'm gonna show you how to install it. This is the engineering equation solver, also known as EES. It pronounced as EES. So we're gonna open the EES software. And at the first glance, it shows you the credential and the licenses. Yep, here we are. This is the environment of EES software, and in this window you can write your equations, your numbers, your variables, your operators, everything you need to do. You can write over here. You can also write some comment for your equations, and yep. Let us start with some simple variables and values. I'm gonna tell that y equals to 3, and you can simply write every equation, every inequation in a single different single lines. So I'm gonna say that x equals to 5 and z equals to 7, and finally p equals to y plus x plus z. This is a pretty simple equation that add 3 different values together. We simply write our variables and give them values, and finally write an equation to add these 3 variables together. To run this equation, and actually to solve this equation, we have a solve button over here, as you can see, but before that we are going to check if we have any error in our syntax. So here we have a check equation button, and when I click on it, it shows that there are 4 equations and 4 variables, as you can see over here, and no syntax error were detected. Completion time, some duration of times, like 0.109 seconds. I'm click on OK, and here at the right side of the editor you can see that or variables are shown over here, and it has no value for them because we didn't run or solve our program or equation yet. So I'm gonna click on the solve button, or you can easily click on F2 button on your keyboard, and it says that as we define x equals to 5, y equals to 3, z equals to 7, and p, which is the sum of these three values, are equal to 5, because 5 equals to 3 equals to 7 equals to I'm sorry, x equals to 5 plus y equals to 3 plus z equals to 7 equals to 15. And it says that no unit problems were detected. This tells us that we have some single variables, okay, and these variables say nothing actually, because it is not telling us about some units, some actual problem or something else. This is like mathematical equations, not related to mechanical engineering or physics or something else. So it doesn't need any unit for that. Consider that we are going to solve some mechanical engineering problem, or some standard gas equations or questions. It should have some units, like we have temperature, so it should be Fahrenheit or centigrade. We have some metric measures like centimeter, meter, yard, feet, and for weight we have pound, ounce, grams, milligrams. But here we don't need any of them, so no unit problems were detected, means that there is no unit, and also there is no error for that. At the other line, it says that the time they solve the problem, it is 125 milliseconds, and the calculation time is 15 milliseconds. That's pretty fast. Okay, so yeah, this is a pretty simple one. And